So for table 2, we have different concentrations. Now, remember when we're using our rate law, let me make a little note up here. Using our rate law, let's go in orange. Rate is equal to K times the concentration of one thing times the concentration of another times the concentration of the third. And that's really what this whole lab is about, right? Where we're going to figure out the order with respect to the first thing, the order with respect to the second thing, and the order with respect to the third thing. That's A, B, and C. Where this may be A, this may be B, and this may be C. This is a little bit thick, isn't it? Okay, A, B, and C. So we figured out in table 1 what the volume we were going to use. The volume we were going to use was 1 mil. The volume we were going to make was 5 mils. And the initial concentration, C1, we read off the carboy, which said, I think, 0.0. What did it say? 2. Is that right? 0.02. Well, let's do the math on it and see if we can figure that out. Well, if it was 0.02, then C2, which is the concentration of this stuff, right? Doing blue. I need some space over here. Can I just do it over here? M1, V1. Let's do not M1, C1. Same reaction, but C1, V1, or same formula, but C2, V2. And so C2 is equal to C1, V1 over V2. I'm going back over here, C1, 0.02. V1 was 1. And V2 was 5. Okay. And so this is 0.02 divided by 5. 0.02 divided by 5 is 0.004. Yeah, that's what, okay. I don't have the notes in front of me, but that's what we were doing with, okay? So yeah, in fact, this was 0.004. And so 0.004, this label also, C1 was the same. This sodium hydrogen sulfide was also 0.02. And so if we have 1 mil of it, doing a dilution of 1 to 5 is going to be that. 0.004. Okay. And I think in trial 2, we actually doubled this amount. So it's going to be, let's do a different color, 0.008, because we put 2 mils of it. This one we did 2 mils of that one, 0.008. And in trial 4, we did 2 mils of that one, 0.008. And in trial 5, we actually had the same concentrations as we had in the beginning. It was 0.004, 0.004, 0.004, because it was the same. This was 1 mil, 0.004. And if you want to know how I'm getting these numbers, go back up and look at the beginning of this video when I was doing this math over here. Okay, that's where I was getting that. Okay, now I borrowed some notes from a student, and so I'm going to put the data in that she had, and I'll use a different color. She had, or her group had 28.13 seconds, 27.28, and 27.12. And so the average time was 27.51. 13.96, 13.04, 13.22, 13.41. That was the average. 22.98, 25.13. These numbers are really good because, right, we're just doing this with our other eyes, right? 23.76. 12.92. Did I get this right? 13.02. 13.91. It's going to be 13.28. And then 39.23. 41.46. 38.92. And 39.87. And the ice bath temperature was 0 degrees, oops, not 0 degrees Fahrenheit, 0 degrees Celsius. And the temperature of the room temperature was 72.5. No. 72.5 Fahrenheit. Degrees Fahrenheit. And I gotta do a little calculation. I'll do it right here. And we know that Celsius is equal to Fahrenheit if you subtract 32 from it, and then it's a smaller scale, so it's going to be 5/9. Okay, so let's come over here and say 5 divided by 9 times 72.5 minus 32 is 22.5. That's legit. That makes sense. That's about room temperature. 22.5. Degrees centigrade. Okay. Celsius. All right. So that's table 2. And I'm going to do another video for the next step.